On the night of November 29, 2018, at 21:30, Ton Son Nhat International Airport in Ho Chi Minh City, one of Vietnam's largest and busiest airports, was in the midst of a hectic and intense period of operations. At Gate A3, an Airbus A321 passenger aircraft was preparing to operate VietJet Air Flight 356 from Ho Chi Minh City to Buon Ma Thuot. The Airbus A321neo model was considered one of the most fuel-efficient variants in the Airbus A320 family. By 2018, VietJet Air's fleet included nearly 20 Airbus A321s, consisting of both A321ceo and A321neo versions. The aircraft assigned to this flight was an A321neo that had been delivered from Airbus just 1 month earlier and had already entered commercial service. According to the manufacturer's list price at the time, an Airbus A321neo cost about USD $129 million. It is worth noting that most of VietJet's aircraft at the time were acquired through operating leases from international leasing companies, a model that helps airlines reduce upfront capital investment pressure and flexibly adjust the size of the fleet to respond to market changes. The crew assigned to operate this flight consisted of 2 experienced foreign pilots. The captain was from the Philippines, had joined VietJet Air only 6 months earlier, and had accumulated 8,953 flight hours, of which 7,275 hours were on the Airbus A31 type. The first officer was Spanish and had only recently begun operating this route. He had a total of 718 flight hours, including 501 hours on the Airbus A31. On this day, a total of 207 passengers boarded. The entire flight was expected to take just over 1 hour. At 22:20 local time, the Airbus aircraft completed boarding, closed its doors, and finished pre-departure checklists. The crew then established contact with the ground tower and were instructed to taxi to runway 25R. The aircraft began moving along the assigned taxi route. Inside the cabin, flight attendants carried out the final safety checks, instructing passengers to fasten seatbelts, switch off electronic devices, and confirming that all emergency exits were set to the armed position. At 22:25, the aircraft taxied to the holding point. After completing all mandatory pre-takeoff checks, the captain contacted the control tower. The tower cleared Flight 356 for takeoff from runway 25R, reporting wind from 260 degrees at 4 knots. The crew then began the takeoff roll. When the aircraft reached the required takeoff speed, the pilot pulled back on the control stick and the aircraft lifted smoothly into the air. After retracting the landing gear, and while still in the vicinity of Ho Chi Minh City, the captain contacted the radar area control frequency to request climb to a cruising altitude of 31,000 feet. Once cleared by the controller, the aircraft continued its climb according to the planned route. Upon reaching the cruise altitude of 31,000 feet, its speed and heading gradually stabilized, and Flight 356 continued toward Buon Ma Thuot Airport. After about 10 minutes in cruise, Flight 356 began an approach and landing under visual flight rules. That is, relying on the pilot's visual judgment rather than navigation instruments. The aircraft was preparing to land on runway 09, which is 3,000 meters long and 45 meters wide. Data from the ground weather station showed ideal conditions, clear skies, visibility of 10 kilometers, and light winds, perfect for a safe and smooth landing. The Airbus A321 made a steady approach to the runway. The landing gear was lowered following standard procedures, and the system confirmed that all 3 landing gear assemblies were locked in place. But at that moment, no one anticipated that disaster was about to strike. When the aircraft was only about 940 feet, around 286 meters above the ground, the captain disengaged the autopilot mode and switched to manual control. However, the auto throttle system remained active, continuing to manage engine thrust to maintain airspeed. At 110 feet above the ground, the captain inadvertently pushed the right control stick too far forward, causing the nose of the aircraft to pitch up abnormally. At that moment, the aircraft's pitch angle reached 3.8 degrees. When the aircraft descended to 40 feet, its rate of descent slowed and its airspeed dropped below the safe threshold. The system, detecting the low speed, automatically increased engine thrust to maintain the target speed. As a result, the aircraft entered a near-ground hover, remaining just above the runway but unable to touch down. An extremely dangerous, borderline flight condition. When the aircraft was only 9 feet above the ground, a critical operational error occurred. The captain suddenly pushed the control stick sharply forward, causing the nose to pitch down rapidly and violently. This abrupt maneuver made the nose landing gear contact the runway before the main landing gear, a complete violation of standard landing procedures. Because the impact was excessively forceful, the vertical speed at the nose gear was roughly double that experienced by the rest of the aircraft's fuselage. The resulting impact forces exceeded design limits, and the shock absorbers were unable to absorb the immense load. This caused the nose gear axle and mounting bolts to fracture instantly. In a matter of seconds, the two wheels of the nose landing gear were torn off and rolled away across the runway. With no nose gear support, the aircraft's nose slammed directly onto the runway, and the fractured axle, along with the lower forward fuselage, scraped violently along the ground. At that moment, the nose-mounted sensors immediately detected severe vibrations and impacts exceeding safe thresholds, triggering continuous alarms. To prevent loss of control, the captain decisively chose not to deploy engine reverse thrust. Inside the cabin, the violent shaking was unmistakable. Every passenger could clearly feel the intense jolt. Many screamed in panic, and some even broke down in tears from fear. The aircraft skidded about 800 meters along the runway. Despite the massive friction, fortunately, no fire broke out. Once the aircraft came to a complete stop, the crew quickly assessed the situation. There was no fire, no smoke, and the cabin structure was still intact enough to maintain pressure. However, considering the risk of fire or short circuits from the electronic systems in the nose section, the crew immediately decided to initiate an emergency evacuation. The evacuation system was activated without delay. 4 main emergency exits were opened, the inflatable slides deployed quickly and stabilized on the ground. Passengers evacuated in an orderly fashion following emergency procedures, sliding down one after another. The flight attendants remained at their posts, continuously assisting passengers, maintaining order, offering reassurance, and directing everyone's actions. All 207 passengers were safely evacuated in under 5 minutes. Although the incident happened suddenly, the entire crew demonstrated swift, calm, and precise responses, strictly following international standards to complete the emergency procedures. The accident resulted in 6 passengers sustaining minor injuries, mainly abrasions or light impact wounds. After the incident, Vietnam's Ministry of Transport immediately instructed the Civil Aviation Authority of Vietnam, CAV, the Airports Corporation of Vietnam, VietJet Air, and relevant units at Buon Ma Thuot Airport to activate their aviation emergency rescue procedures as required. By around noon the next day, technicians removed the damaged aircraft from the runway. Of the 2 detached nose wheels, one was found near the left edge of the runway, not far from the aircraft fuselage. Other flights were only slightly affected, and airport operations quickly resumed. In a subsequent press release, VietJet Air issued an apology to all passengers and confirmed that the Airbus A321 involved was a newly delivered aircraft recently received from Airbus. The airline also pledged full cooperation with authorities to investigate the cause of the incident. On December 1, the CAV decided to suspend the entire flight crew, including the captain, first officer, cabin crew, and ground personnel involved in the flight, to facilitate the accident investigation. The Flight 356 incident was classified as a Category B event, meaning it posed a serious threat to flight safety, a highly dangerous classification for modern commercial aircraft. Although the nose landing gear does not bear the full passenger load during landing, it plays a critical role in keeping the aircraft rolling straight, stable, and decelerating on the runway. Therefore, nose gear or tire failure can easily cause the aircraft to lose balance, veer off the runway, or even overturn or collide severely. Analysis of the Flight 356 incident showed that the nose gear suffered impact forces beyond its design limits, causing the shock absorber to fail. This led to severe damage to the landing gear axle and bolt structure. The force of the impact was so great that the mechanical system could not withstand it, triggering a chain reaction that affected the tires and parts of the fuselage. The primary cause of the accident was the captain's incorrect operation during the landing phase, specifically at about 110 feet above ground level. The captain inadvertently pulled the control stick slightly, causing the aircraft's nose to pitch up and the rate of descent to slow. The automatic thrust system therefore increased engine power to maintain flight speed, causing the aircraft to hover just above the runway. When the plane was only 9 feet above the ground, the captain mistakenly pushed the control stick forward, completely violating the technical operations manual. This sudden nose-down movement caused the nose gear to touch down first, resulting in serious damage and triggering a series of subsequent mechanical failures. In addition, before landing, the cockpit did not issue any warnings about the landing gear, tires, or hydraulic system. At the time of the incident, Buon Ma Thuot Airport had good weather conditions, high visibility, and light winds. The aircraft itself also had no known technical fault records. These factors directed the investigation's focus toward human factors, especially the pilot's operational experience. The crew's coordination during the incident, as well as the airport's infrastructure conditions, also became key points of attention in the investigation. A senior captain noted that Buon Ma Thuot Airport is a domestic airport whose infrastructure is not yet modernized. The runway is not completely level, and the taxiway lighting system is relatively weak. And the airport was not yet equipped with a precision approach landing system, which is especially important for landings at night or in low-light conditions. This became a factor that increased the difficulty of approach and landing, particularly for pilots unfamiliar with the airport's terrain or with less flight experience, making the situation even more challenging. In this case, all the crew members of Flight 356 were newly joined VietJet Air pilots, and they may not have been fully familiar with the airport's characteristics, which led to a failure to completely control the situation at the critical moment. However, it should still be acknowledged that in the moment of crisis, the crew's calm response played a key role in safeguarding the lives of the passengers. This serves as the best testament to VietJet Air's systematic and professional pilot training quality, demonstrated not only in skills but also in the sense of responsibility and judgment shown in life-or-death situations. According to Aviation Safety Network data, the Airbus A321 has historically been involved in several serious accidents, 2 of which resulted in significant loss of life. The most serious case occurred on October 31, 2015, when a Metrojet Airbus A321-231 from Russia was destroyed mid-air over Egypt by a bomb, killing all 224 people on board. Another took place in 2010 in Pakistan, where an overloaded aircraft, combined with pilot error in severe weather, resulted in 152 fatalities. The VietJet Air Flight 356 incident serves as a clear warning. No matter how advanced an aircraft may be, aviation safety is always a highly complex ecosystem in which human factors, technology, and infrastructure must operate in close coordination and remain ready to handle even the rarest and most unexpected emergencies.